What really happens to your arteries? When you sit too long, they say sitting is just rest. A pause between movements, a harmless part of modern life. But inside your body, stillness is not neutral. When the legs remain bent for hours, blood flow slows, muscles fall silent. Arteries, elastic tubes built for rhythm and pressure, experience a different kind of environment. The river of blood changes speed. The lining of the vessels senses this shift. What happens to your arteries when movement disappears for most of the day? Does the body simply wait, or does it begin to adapt in ways that are not immediately visible? Because arteries are not passive pipes. They are living tissue, responsive, sensitive, constantly adjusting to force and flow. And prolonged sitting quietly alters both. This is the unseen physiology of stillness. Let's begin. 1. The first signals. The body is built for motion. Within minutes of sitting down, the skeletal muscles in the legs reduce their electrical activity. The large muscles of the calves and thighs, normally contracting subtly even while standing, fall quiet. These muscles act as auxiliary pumps, squeezing veins and helping push blood back toward the heart. When they become inactive, circulation in the lower limbs slows. Blood does not stop. The heart continues its rhythm, but velocity decreases. The river moves more gently through the vessels of the legs, and gravity begins to exert a stronger influence, encouraging fluid to pool in the lower extremities. Arteries sense this change. The walls of blood vessels are lined with specialized cells that respond to flow. Reduced movement means reduced mechanical stimulation. Within 30 to 60 minutes of uninterrupted sitting, measurable declines in arterial dilation capacity can occur in the legs. At the same time, metabolic activity drops. Muscles that are not contracting demand less oxygen and glucose. Local blood flow adjusts downward to match this lower demand. This is not immediate damage. It is adaptation. But adaptation to stillness begins quickly. The first signals are subtle. A slight feeling of heaviness, warmth, or stiffness in the legs. These sensations reflect shifts in pressure, circulation, and fluid balance. The body is responding to immobility in real time, recalibrating flow, pressure, and vessel tone. Stillness, even in its earliest stages, has a physiological signature. Tier 2. Flow and friction arteries are not rigid pipes. They are dynamic tubes designed to sense and respond to the force of flowing blood. As blood moves across the inner lining of an artery, it creates shear stress, a gentle frictional force. This mechanical stimulus is essential. It signals the vessel to produce nitric oxide, a molecule that relaxes smooth muscle cells and keeps the artery flexible. Nitric oxide is a messenger of dilation. It tells the vessel wall to soften, widen, and maintain elasticity. It also discourages unnecessary clot formation and limits inflammatory signaling along the vessel lining. When sitting reduces blood flow velocity, shear stress decreases. Less friction means less stimulation for nitric oxide production. The artery subtly shifts toward a more constricted state. Over time, repeated reductions in shear stress can impair the vessel's ability to dilate efficiently. The change is not dramatic in a single sitting session. But arteries adapt to their environment. If daily life involves prolonged immobility, the vascular system experiences extended periods of reduced mechanical signaling. Flow becomes steadier, slower, less dynamic. Healthy arteries prefer variation. Pulses of increased flow during walking, standing, climbing. These fluctuations maintain responsiveness. Without them, the biochemical signals that preserve flexibility diminish. Friction, in this context, is protective. And when it fades, a vascular tone begins to recalibrate towards stiffness. The river shapes its banks. When the current slows, the banks change with it. 3. The endothelial engine. The innermost layer of every artery is called the endothelium. Though only one cell thick, it functions as an active organ. These endothelial cells monitor pressure, detect chemical changes, and regulate interactions between blood and vessel wall. They release nitric oxide to control dilation. They modulate inflammatory signals. They prevent platelets from sticking unnecessarily. They are guardians of smooth circulation. During prolonged sitting, the endothelial environment shifts. Reduced shear stress alters gene expression within these cells. Nitric oxide production declines. At the same time, subtle increases in oxidative stress may occur, particularly if metabolic factors such as elevated blood glucose or lipids are present. The endothelium becomes less responsive. In laboratory studies, on even a few hours of uninterrupted sitting can temporarily impair endothelial-dependent dilation in leg arteries. This effect is reversible with movement, but repeated exposure creates repeated strain. The endothelial engine thrives on rhythm, expansion and contraction, acceleration and deceleration of flow. Stillness disrupts that rhythm. Without regular mechanical stimulation, regulatory balance tilts. Anti-inflammatory signals weaken slightly. Vascular tone trends toward constriction, and these changes are microscopic. There is no pain receptor inside the arterial wall signaling distress, but the inner lining registers the difference, and over time, small disruptions in endothelial function can accumulate into measurable vascular dysfunction. The most delicate layer of the artery depends on motion to maintain its equilibrium. 4. Silent vascular stiffening. Arteries are built from layers of smooth muscle and structural proteins, primarily elastin and collagen. When elastin provides stretch, collagen provides strength. In youth, elastin fibers allow arteries to expand easily with each heartbeat, buffering pressure as blood is ejected from the heart. With age and repeated mechanical or metabolic stress, elastin gradually degrades and collagen becomes more dominant. This process increases arterial stiffness. Prolonged sedentary behavior contributes subtly to this shift. Reduced nitric oxide availability and recurrent endothelial dysfunction promote structural remodeling of the vessel wall. Smooth muscle tone may remain slightly elevated. Over time, repeated periods of low-flow states influence how these structural proteins are maintained and repaired. Stiff arteries do not expand as efficiently. When the heart pumps, pressure rises more sharply. The pulse wave travels faster through rigid vessels, increasing strain on delicate microvascular networks in organs like the brain and kidneys. The progression is gradual. There is no sudden symptom announcing early arterial stiffening. Blood pressure may remain within normal range for years. Physical sensation offers little warning, but imaging studies show that individuals with chronically sedentary lifestyles often exhibit higher measures of arterial stiffness compared to those with regular movement patterns. Stillness, repeated daily, it becomes a structural signal. Elastic fibers experience less dynamic stretching. The vessel wall adapts to a narrower range of motion. 5. Myths of just resting. Sitting is often described as rest, but biologically, rest and immobility are not identical. True physiological recovery, such as sleep or intentional relaxation, occurs within a dynamic internal environment. During sleep, hormones fluctuate in cycles. Blood pressure dips and rises in rhythm. Repair proteins activate, where the cardiovascular system follows structured patterns of restoration. Prolonged sitting during waking hours is different. Muscle contraction drops to minimal levels. Caloric expenditure declines sharply. Enzymes responsible for breaking down circulating fats, such as lipoprotein, lipase, reduce their activity in inactive muscle tissue. As a result, triglyceride clearance from the bloodstream slows. Metabolism shifts downward. With reduced muscular demand, glucose uptake declines. White blood flow in the lower limbs becomes more stagnant. Shear stress along arterial walls diminishes. The endothelium receives fewer mechanical signals to maintain flexibility. Restorative rest supports repair. Prolonged immobility reduces stimulation. The body is designed for alternating states: contraction and release, pressure and relief, motion and pause. When pause dominates for extended hours, vascular tone adjusts to that quieter baseline. This is not exhaustion recovery. It is reduced physiological engagement. Sitting is not inherently harmful in short intervals. The human body tolerates stillness well when balanced with movement. The issue arises when immobility becomes the dominant daily pattern. Rest restores systems. Chronic stillness recalibrates them, and arteries respond accordingly. 6. Long-term arterial impact. Over years, repeated daily inactivity shapes the vascular landscape. Reduced endothelial responsiveness, even if temporary at first, can become more persistent. Lower nitric oxide availability allows smooth muscle tone within arteries to remain slightly elevated. Blood pressure may gradually rise as vessels lose some of their elastic buffering capacity. At the same time, metabolic shifts associated with sedentary behavior, including higher circulating triglycerides, elevated glucose excursions, and increased low-grade inflammation, interact with the arterial wall. The endothelium, when exposed repeatedly to these biochemical signals, becomes more permeable. Lipid particles such as LDL cholesterol can infiltrate the inner layers of the artery. Immune cells migrate into the vessel wall, initiating the earliest stages of plaque formation. Atherosclerosis does not begin with obstruction. It begins with microscopic lipid accumulation and inflammatory signaling inside the vessel lining. Prolonged sitting alone is not the sole cause. But when combined with metabolic risk factors, inactivity amplifies the environment that allows plaque to develop. As plaques grow over decades, arteries narrow and stiffen further. The heart must generate higher pressure to maintain adequate flow. Cardiac workload increases. The process is gradual. There are no early alarms, no sharp pain during initial plaque formation. The body compensates silently, adjusting pressure and circulation to maintain function. But compensation has limits. In the vascular system remembers repeated patterns, and chronic immobility becomes one of those patterns etched into arterial structure. 7. Reading the circulatory signals. The body communicates through sensation. After long periods of sitting, legs may feel heavy. This reflects venous pooling, blood collecting in lower limb veins due to reduced muscular pumping. Increased venous pressure pushes fluid into surrounding tissues, leading to mild swelling. And ankles may appear slightly enlarged by evening. Socks leave deeper impressions. These are signs of fluid redistribution, not random discomfort. Cold feet can also emerge during prolonged immobility. With reduced muscle activity, metabolic heat production decreases. Peripheral blood flow may decline slightly as vessels constrict in response to lower demand. Reduced stamina during physical activity can reflect deconditioning of both muscle and vascular responsiveness. Arteries that are less accustomed to dynamic dilation respond more slowly to increased demand, making circulation feel less efficient. These sensations are early circulatory feedback. They do not indicate immediate disease, but they reveal how the vascular system adapts to patterns of use. Arteries prefer movement. Veins rely on muscle contraction. Endothelial cells depend on changing flow to maintain balance. When signals like heaviness, stiffness, or swelling appear consistently, they represent shifts in pressure dynamics and fluid mechanics within the circulatory network. The body rarely moves from health to crisis without intermediate signs. It adjusts gradually, it signals quietly, it adapts to repetition, and in those small daily sensations, the circulatory system reveals the story of stillness. 8. The reversal window arteries are adaptive structures. Just as they respond to stillness, they also respond to movement. The vascular system is not fixed in one state. It continuously remodels according to mechanical signals, blood flow patterns, and metabolic conditions. This creates what researchers sometimes observe as a reversal window, a period in which functional changes remain modifiable. When movement resumes after prolonged sitting, blood flow velocity increases. Shear stress rises again along the endothelial lining. Nitric oxide production improves. Arteries dilate more effectively. The inner surface regains part of its responsiveness. With even brief interruptions in sitting, standing, walking, contracting large leg muscles can restore measurable endothelial function in the lower limbs. This does not erase structural aging. It does not dissolve plaque that has formed over decades. But it demonstrates something essential about vascular biology. Function often changes before structure. Early dysfunction is flexible. Late structural damage is less so. The circulatory system remembers patterns, but it also recalibrates when patterns shift. Arteries are living tissue. They are influenced daily by pressure waves, muscle contractions, and the rhythm of flow. Stillness writes one version of adaptation, movement writes another, and within that adaptability lies the quiet resilience of the human vascular system. Aging is natural wear over time. Inactivity can accelerate certain aspects of that wear, quietly, without announcement. The arteries are not silent structures. They respond to flow, to pressure, to movement, or the absence of it. Prolonged sitting does not cause sudden collapse. It creates gradual shifts, reduced shear stress, subtle endothelial changes, progressive stiffening over years. The process is slow, cumulative, and often unnoticed until much later. The body adapts to patterns, and daily stillness becomes one of those patterns. Health is not sudden, it is cumulative. Understanding the body is the first step to respecting it. And this channel explores the science behind everyday health topics. If you found this documentary insightful, consider subscribing for more evidence-based explorations of human physiology. Share your thoughts below, and stay tuned for the next deep dive into how the body truly works. Your circulation never stops moving. The question is, how often do you?